Okay, now refer to the information above. We want to write this ratio as a fraction in simplest form. Then explain what it means. So if we're going to write it as a fraction, we're going to use this form, 60 over 90. And we want to simplify it as short as possible, or as small as possible. So what is the greatest common factor for 60 and 90? Okay, 10 would work. Okay, what about 30? Would 30 work? Yeah, 30 works too. Okay, if I was looking at it, 10 would be the first one I would try too, since they both end in 0. So let's say that, let's first do it if we saw it was 30. So if we saw 30 was the greatest common factor, then I'm going to divide. So what is 60 divided by 30? It's 2. And if I divide 60 by 30, I have to divide 90 by 30. That's what keeps it balanced. 90 divided by 30, I'm sorry. Should be 2, right? And then 90 divided by 30 is 3. Keeping it balanced. So that should be 2 over 3. Now, what if you didn't see 30? What if you saw 10? Okay, what would happen then? So 60 over 90. If I divided the top by 10 and the bottom by 10, that would give me 6 over 9. Okay, could you reduce 6 over 9? Yeah, they're both divisible by 3. So if I divided the top by 3 and the bottom by 3, that would be 2 over 3. So even if you don't choose the greatest common factor to start with, if you'll always just check, can it reduce again? You'll still get the same correct answer. Just keep checking. Make sure that after you reduce it the first time, can it reduce any more? This one cannot after we reduce it down to 2 over 3. Write each one of these ratios as a fraction in simplest form. Okay, what'd you get on A?
2 over 3. On A, I could not find a way to simplify it.
Okay, so what does it write as a fraction? It would be 15 over 18? So I would just start with 2. Can I divide those by 2? No, so try 3. Can I divide by 3?
Yes. Oh, I didn't know.
What'd you do?
I got confused because I forgot that 3 could go to 8.
Okay. But you see now, right, how to do it? So I divide by 3. So do that really quickly. And tell us what you would get.
5 over 6.
5 over 6. So 15 over 18 reduces to 5 over 6. That's correct. That's how you got to 2 over 3.
I divided by 20 divided by 10.
Okay, so you picked 10 right off the bat as a GCF. Okay, and that is the greatest common factor. Anybody do a different number besides 10 first? Everybody saw that and went straight to 10? That's good. If they both end in 0, 10's always a good bet to go with. It's easy to reduce by. Okay, but some people may look at that and said they were even and divided by 2, right, to get 10 over 15. And then 10 over 15, they're both divisible by 5. So if you did it that way, that could also work. Just make sure, again, you're checking after you simplify, can it simplify again? Okay, here on this one, we want to determine whether the ratios 250 miles in 4 hours and 500 miles in 8 hours are equivalent. So there's a couple of different ways we can do these problems. Let's first do it the way we just did the last one. Okay, so I've got 250 miles in 4 hours. So I want to see, what does that ratio reduce to? Well, since the bottom number is 4, I'm going to see, can they both be divided by 4? So can 250 be divided by 4? Well, let's see. Can 4 go into 25? Yes, 1 time. And that would give, 6 times. And that would give me 1 left over. And then it would go into 10, not evenly. Okay, so it would give me a decimal. So I'm not going to do that. So since I see they're both even, let's just divide them both by 2. Okay, they're both even numbers, so divide them both by 2. 250 divided by 2 is 125. And 4 divided by 2 is 2. So this fraction will reduce to 125 miles in 2 hours. Okay, let's look at my other fraction. So my other fraction is 500 miles in 8 hours. Okay, so again, both these are even. So I would just divide them both by 2. So if I do that, that's going to give me 250 miles over 4 hours. Right, I get that by dividing by 2. And now both of those numbers are even, so I can divide by 2 again. So that's going to give me 125 miles over 2 hours. So look at what my fractions reduced to. The first one reduced to 125 over 2. The second one reduced to 125 over 2. So the question is, are these fractions equivalent?
Yes.
Okay, well, what does that word equivalent mean?
Equal.
They're equal to each other. They're the same. Well, yeah, if I reduce both these fractions, I get it to be 125 over 2. So that means they're the same fraction. It's the same ratio. So I would say, yes, they are equivalent. Okay, looking at this one. Miss Garcia has 80 folders for 20 students. Mr. Walker has 75 folders for 25 students. Will a student in Miss Garcia's classroom receive the same number of folders as a student in Mr. Walker's classroom? And then justify your answer. So this time they're not giving me the rates. I'm going to have to discover them on my own. So there's 80 folders for every 20 students in Miss Garcia's. So set that up as a rate. 80 folders for every 20 students. Okay, can I reduce that? Okay, yes. What is the GCF? What can they both be divided by?
Yes,
20. So 80 divided by 20 is 4 folders. 20 divided by 20 is 1 student. So what does this ratio mean? That means there will be 4 folders for every 1 student. So if you're in Miss Garcia's classroom, you're going to get 4 folders. Okay, let's look at Mr. Walker. Mr. Walker did 75 folders for 25 students. So we set that up. 75 folders over 25 students. So what's my GCF there? 25? Can they both be divided by 25?
Yes.
They can. So we divide by 25. 75 divided by 25 is 3 folders. And then 25 divided by 25 is 1 student. So in Mr. Walker's, every student's going to get 3 folders. Where in Miss Garcia's, they're going to get 4. So the question is, will a student in Miss Garcia's classroom receive the same number of folders? No. And then how could we justify that? Well, we would say Garcia gets 4 folders. And Mr. Walker's gets 3. So Garcia gets 4 folders. And Walker only 3 folders. That would be your justification. And the second one reduces to 3 over 2. So no, they are not equivalent. That's correct. Any questions on that one? Do I need to go over that one in more detail? Pick a number, 1 through 6.
That would be 3.
Pick a number, 1 through 2.
It's 1.
Okay, on D, what did you get as your answer? I can't hear you. You don't know? Okay, so how would we set it up? What is D here? How would we set that fraction up? 100 sheets of paper and 2 notebooks. We should set that up as 100 over 2. Now, can I reduce that fraction? Do they have a common factor? What is it? They're both even, so you can divide them both by 2. 100 divided by 2 is 50. 2 divided by 2 is 1. So the first one reduces to 50 over 1. The second one, we set it up. It should be 250 over 5. Those are both divisible by 5. 250 divided by 5 is 50. 5 divided by 5, 1. So are those equivalent? Yes, they both reduce to be 50 over 1. And the last one, a community pool requires there to be at least 3 lifeguards for every 20 swimmers. There are 60 swimmers and 9 lifeguards at the pool. Is this the correct number of lifeguards based on the above requirements? And justify your answer. So what did we get on that one? Anybody get an answer? Yes, you got an answer?
I say it is,
Okay, how did you get that they were the same?
because there are 9 lifeguards and 60 people, and 3 groups of 20 and 3 groups of lifeguards for like 3 divided by 3 times, yeah, 3 times 3 is 9, and when they need 3 lifeguards for every 20 people, and 3, and there's 3 groups of 20 and 60,
So you said 3 lifeguards for every 20 swimmers. And we want to know, is this the same as 9 lifeguards for 60 swimmers? So you said to get from 3 to 9, you multiply by 3, right, to get 9. And if I multiplied by 3 down here too, that would give me 60. Okay, so you got them both being written as 9 over 60. So they're equivalent, they work. The other way you could have done it to stay the way we've been doing things, take 9 over 60 and reduce it. Okay, divide by 3, divide by 3. That would give me 3 over 20. So I could make them match as 3 over 20, or I could make them match as 9 over 60. Either way, they're equivalent. Okay, so yours is correct.